Hello everyone. In this video, we'll see the basic relationship between the pixels. So, to define the relationship between the pixels, here we have neighbors of a pixel, adjacency or connectivity, and the distance measures. In this video, we'll see only the first two, and for the third one, I have a different video for this. Coming to the neighbors of a pixel, suppose this is an image. Each image, it is made up of pixels. So here these all boxes are nothing but the pixels. Now here we will consider these pixels, that is P1, P2, P3 up to P8. Okay, P1, P2, P3, P4, P5, P6, P7 and P8, and this is the center pixel. And we will see that we can see that the pixels P2, P4, P6 and P8, these are called as the adjacent pixels. Okay, so these are nothing but the horizontal pixels. These P8 and P4 are horizontal, P2 and P6 are vertical. And these P1, P3, P5 and P7, these are called as the diagonal pixels. Okay, now here if you see the second image, here this is our pixel of interest, and the coordinates for these are x comma y. So here these are the vertical pixels and these are the horizontal pixels. If you can see, or if you observe here, you can see that the value of the x will be increased as we go from left to right. That is x minus 1, then it is increased to x, then x plus 1. And the value of y, it will be increased when we move from top to bottom. That is y minus 1, y plus 1. Here the pixels with the green line here, these are called as vertical pixels and these are called as horizontal pixels. So these pixels which are at the corners, these are called as the diagonal pixels. Okay, so here we are considering the center element as x comma y, and each of these pixels, these are represented with respect to this pixel. So this is basically called the neighborhood of pixels or the neighbors of a pixel. Now next we will see the types of the neighborhoods. That is, first we have 4 neighborhood pixel. Suppose we have like a pixel P whose coordinates are x comma y, and it has 4 horizontal and vertical neighbors, that is 2 horizontal and 2 vertical neighbors, which are represented like this. So x comma y, this is our pixel of interest, and here these pixels are nothing but the 4 neighbors of the pixels, and the values for these, or the coordinates for these, are nothing but x comma y plus 1, x comma y minus 1. These two are the vertical pixels. X minus 1 comma y and x plus 1 comma y, these are the horizontal pixels. So here these are nothing but the pixel coordinates. So this is called as the 4 neighbors of pixels. That is, it is represented by n4 of p. It means that 4 neighbors of pixels. Next is one more thing here is each pixel is unit distance from x comma y. So in this neighbor pixel, or the 4 neighbors of p, here each of these pixels is at unit distance. That is, the pixels which are adjacent to each other, these will have a unit distance always. And some of the neighbor locations of the pixel P, these will lie outside the digital image if x comma y is on the border of the image. Okay. Now next is the diagonal neighbors. So it is 4 diagonal neighbors of P, which is represented by nd of P, that is diagonal neighbors of P. Now here you can see this image. This is the center center pixel, or the pixel of our interest, and here these pixels are called as the diagonal pixels. Okay, these were these blanks were nothing but this one, that is the neighbors, and here these are nothing but the diagonal neighbors. Okay, but these are not adjacent to P, whereas these are diagonal to P. Now these are the coordinates of the diagonal neighbors. So it is like x plus 1, y plus 1, then you have x plus 1, y minus 1, then you have x minus 1, y plus 1, and x minus 1, y minus 1. Next, this was 4 neighborhood. This was the diagonal, 4 diagonal neighbors or 4 diagonal neighborhood. Now comes the 8 neighborhood, that is 8 neighbors of P. Now this is our P. Here this is nothing but the 8 neighbors of P. That is, it is the combination of the 4 neighborhood along with the diagonal neighborhood. So you can see it consists of all the pixels here, that is 4 neighbors, that is the horizontal, vertical, and the 4 diagonal neighbors. This is nothing but the 8 neighbors of P. So here n8 of P is nothing but the combination of both n4 of P and nd of P. Next, coming to the adjacency, or it is also called as connectivity. Two pixels are said to be adjacent if they are neighbors of each other and they have the same gray level. Okay, suppose we will consider a set of here we'll consider a set of intensity values which is given by V, which is used to define the adjacency. Now for binary image, V will be equal to 1, that is if we are referring to the adjacency of pixels with value 1. Then we have that is in grayscale image, the idea will remain same, but the set V, it consists of more elements. That is, for example, in adjacency of pixels with a range of possible intensity values from 0 to 255, this set V, it could be a subset of 256 values. That is 0 to 255, it will be 256 values, whereas in binary we have V is equal to 1. So there are 3 types of adjacency. First is 4 adjacency, then you have 8 adjacency and m-adjacency. M-adjacency is nothing but the mixed adjacency. We'll see first what is the 4 adjacency. 4 adjacency is nothing but, here we can define it as 2 pixels P and Q with values from V are said to be 4 adjacent if Q is in the set n4 of P. Okay, this Q, it must be in the set n4 of P with respect to P. So suppose here I will consider this as the image and these are the pixel values. And here we are taking V is equal to 1, which means that only the elements from this set can be included for making connections. That is, suppose if I choose this pixel, here this can be connected to only, that is, if I consider this pixel here, it can be connected to only this pixel. Okay, because the value of this pixel is 1. I cannot connect this pixel with these pixel, this one or this one, because the values of these pixels are zeros, as we have taken the set as V is equal to 1. Now here how we can connect using the 4 adjacency is, we can connect this pixel to this pixel because the value is 1, as we have taken V is equal to 1. We cannot have a connection for these pixels. Okay, although these are adjacent, but we cannot connect this using a 4 adjacency because our set is V is equal to 1. And also we can connect this one with this one like this. So again this will be a 4 adjacency. Okay, next we'll see 8 adjacency. So 2 pixels P and Q with values from V are said to be 8 adjacent if Q is in the set N G of P. Okay, so here you can see again we'll take the pixel arrangement for the image here with set v is equal to 1. Now we will see how we can connect this using the 8 adjacencies. So here this can be connected to this number 1, that is this pixel can be connected to this pixel because its value is 1, as we have taken v is equal to 1. So these two can be connected. This is nothing but the 4 adjacency. Then again we can connect this to this. This is nothing but again the 4 adjacency. Now we want to connect using the 8 adjacency. So 8 adjacency is we can connect it diagonally like this. This is 8 adjacency. Okay. And also this one, it can be connected to this one. So again here it is 8 adjacency. Fine. This is 4 adjacency. This one is 4 adjacency. Whereas we are connecting this directly, instead of going from this to this, this is 8 adjacency. And also here this is 8 adjacency. Fine. But when we do this, here there will be some kind of ambiguity. Okay. Now next is, so here we are taking here adjacency, therefore it will create some ambiguous, that is it will create some ambiguity here, that is confusion. So next I will show you one example regarding this. So suppose we have a binary image and we have a set v is equal to 1, and we have to and this is the pixel arrangement for an image. Okay. Now if I consider this pixel, okay, if I consider this pixel, I can connect here this pixel to this pixel. So it is nothing but the 4 adjacency. Okay, adjacent connection, 4 adjacency. If I connect this pixel with these two, then these two are what? These two are 8 adjacency. Okay, then this was for the binary image. If I take a grayscale image with the set v is equal to 1, 2, 3 up to 10, okay, I can connect these numbers from this which are given in the set. Suppose this is the pixel arrangement. I will consider here I will take this pixel. Now this pixel, it can be connected to this pixel value. This 2 can be connected to 4. So this is what? This is 4 adjacency. So why? Because 4 is in this set. 37 is not there, 55 is not there, 198, 90 are not there. 1 is also not there. But here 10 is there and 7 is there, which can be connected using what? Using 8 adjacency. Fine. Now again in this set of pixels, here you have 8, but neighboring to 8 you don't have any numbers which are which belongs to this set. So this 8, it cannot be connected, therefore it is not connected. Similarly here you can see you have 1 where the surrounding pixel values are zeros, so it cannot be connected to any of these, therefore this is also not connected. Okay. So next we have m-adjacency. M-adjacency, here 2 pixels p and q with values from v are said to be m-adjacent if q is in the set n4 of p, q is in the set nd of p, and the union of n4 of p and nd of p has no pixels. Okay, then it is called as m-adjacency. So for this we'll take an example here. Suppose again we'll consider the same pixel arrangement with the set v is equal to 1. Now how I can connect using the 4 adjacency and 8 adjacency, we can see here. So here I can make a connection between these two and these two using the 8 adjacency. Then again I can have a connection between these two. I can have a connection between these two and these two, or I can have many connections. Okay, I can have different paths, but because here this consists of 4 adjacency as well as the 8 adjacency, here this will create some ambiguity, and when we make the connection, we uh, we need to make sure that they are unique. That is, there must be a unique path between the elements, and it must not give rise to any ambiguity like this, that there must not be any 4 adjacency, there must not be any 8 adjacency. So here it must be unique. So here comes the mixed adjacency. That is, now we can define what is m adjacency. So here the rule of m adjacency is that whenever you have to make connections, and if there are one ways, that is, it can be connected using there are many ways, that is, it can be connected using 4 adjacency or 8 adjacency, then we need to give priority to the 4 adjacency. Like here we have, when I want to connect to this, that is, I can connect using 8 adjacency, okay, or I can connect this using 4 adjacency also. That is, I can go from this pixel to this pixel to this pixel, that I'll connect first here. This is nothing but the 8 adjacency, so here we cannot make any 4 adjacency. But when we want to go to this pixel, what we have to do is, first we need to go from this to this pixel, then we need to go from this to this pixel, okay. So here the ambiguity is resolved here. That is, what we were doing here, we were going directly from this to this, and also we are going from this to this, okay. But when we go for m adjacency, even though we can have a connection using 8 adjacency, we should not go for 8 adjacency. We need to give priority to 4 adjacency instead of 8 adjacency, okay. So this is about the m adjacency, which will solve the ambiguity here. That is, it will remove the ambiguity. So this is about the 4, 8 and m adjacency. Hope you have understood. Thank you.